You know how sometimes you just want to cut through the noise and really understand something big?
Yeah, get straight to the heart of it.
That's our plan today. We're doing a deep dive into something pretty huge from the world of astronomy.
We are indeed. We're talking about the very first confirmed lone black hole found drifting through our own Milky Way galaxy.
A lone black hole. It sounds, well, lonely, but also really significant.
It absolutely is, because until now, pretty much every black hole we've confirmed had a companion star nearby. That was key.
Right. So today, we want to unpack why finding one on its own is such a big deal, what it tells us, drawing mainly from that big paper in the Astrophysical Journal and some related reports.
And, to touch on the challenge, how do you even spot something like that? It's not easy.
Okay, so lone black hole, let's start there. Why is the lack of a companion star the headline news here?
Well, think about how we usually found black holes. They're, black, right? They don't give off light.
Invisible, basically. Gravity traps everything.
Exactly. So we needed a signpost. The companion star was that signpost. The black hole's gravity would pull gas off the star.
And that gas would heat up and glow brightly, especially in X-rays.
Precisely. Millions of degrees, super bright X-rays that our telescopes could see, or we'd see the companion star wobble in a weird way.
Like it was orbiting something massive but invisible.
Yes, that orbital dance told us something unseen, something heavy was there.
So take away the companion, and you take away our main detection methods. It's like trying to find a ninja in the dark.
That's a good way to put it. So finding this one required a different approach entirely.
How did they pull it off then? Who figured this out?
It was a team led by Kailash Sasahu over at the Space Telescope Science Institute in Baltimore. They actually spotted signs of a dark object back in 2022.
A dark object moving through Sagittarius.
That's right. Something massive, not shining, no obvious partner. But there was initially a bit of debate.
Oh, what was the debate about?
Some scientists wondered if maybe it wasn't a black hole, but perhaps a neutron star.
Okay, another super dense dead star, but not quite a black hole. So cosmic whodunit.
Kinda, yeah. So Sahu's team had to prove it. They needed more evidence.
How did they get that without the usual clues?
They kept observing. They used a ton of data from the Hubble Space Telescope building on observations from 2011 to 2017 with newer data from 2021 and 2022, and they combined that with super precise measurements from the Gaia space probe.
So years of staring at the right spot, what were they looking for?
This is the cool part. Gravitational lensing.
Gravitational lensing. Okay, sounds complex. Break that down for us. Einstein territory, right?
Definitely Einstein. Think of it like this. Massive objects like black holes warp space and time around them. It's like putting a heavy ball on a trampoline. It creates a dip.
Okay, got the warp trampoline sheet in my head.
Right. Now, if light from a distant star passes through that warped area near the black hole,
Its path gets bent, like a
Yep.
marble rolling past the dip.
exactly, its path gets bent. So this lone black hole happened to drift almost perfectly between us and a much more distant star. Not a companion, just a background star.
Ah, a chance alignment.
A very fortunate one for astronomers. As the black hole passed by, its gravity acted like a lens.
A lens. So it, what, magnified the background star?
It did two things we could measure. First, it magnified the light from the background star, making it appear temporarily brighter.
Okay.
Second, it caused the apparent position of that background star to shift slightly in the sky and then shift back as the black hole moved away.
Whoa. So you don't see the black hole itself, but you see it affect the brightening and the wobble on a star far behind it.
That's the genius of it. You're using the background star as a probe to detect the invisible object in front.
It's seriously clever. So what did this lensing effect tell them about the object? Did it confirm it was a black hole?
It did, because the amount of brightening and the amount of positional shift are directly related to the mass of the object doing the lensing.
Ah, so they could weigh it.
They could weigh it. And the calculations showed this object has a mass about 7 times the mass of our sun.
7 solar masses. And that's important because
Because it rules out the neutron star possibility. Neutron stars, while super dense, have a theoretical upper limit. They can't really get much heavier than about 3 times the mass of the sun before collapsing further.
So 7 solar masses is definitely too heavy. It had to be a black hole.
Exactly. The mass measurement was the clincher.
Okay, so we have a confirmed lone black hole, 7 times the sun's mass. Where is it?
It's about 5,000 light years away from us, still within our Milky Way galaxy.
5,000 light years. That sounds far, but in galactic terms.
It's relatively close. Consider Sagittarius A, The supermassive black hole at the galactic center that's more like 27,000 light years away.
Yeah.
So this one's practically in our neighborhood, cosmically speaking.
Wow, okay. So finding one, confirming its mass.
Yeah.
What does this mean for the bigger picture? What are the implications?
Well, it really opens things up. We mostly understood black hole formation in the context of binary systems, you know, two stars born together.
Right, one collapses into a black hole, maybe stays with its partner.
Or maybe gets kicked out during the supernova explosion. This discovery supports ideas like that black holes can be ejected from their birthplaces. Or maybe some massive stars just form and die in isolation to begin with.
So it suggests there could be many more black holes out there than we previously estimated, just drifting silently.
That's the strong implication, yes. A whole population of hidden wanderers. We've just found the first confirmed example.
It's like realizing there's a whole class of animals you knew might exist, but had never actually seen in the wild before.
A very good analogy. And now we have a tool, gravitational lensing, that's proven it can find them.
So what's next? Are they actively looking for more now?
Oh, absolutely. Sahu's team and others are definitely hoping this is the tip of the iceberg. There's a lot of excitement about a future mission.
Which one?
The Nancy Grace Roman Space Telescope. It's due to launch around 2027.
And it's suited for this kind of search.
Perfectly. It's designed to survey huge patches of the sky with incredible sensitivity, making it ideal for spotting these brief, subtle gravitational lensing events. It could potentially find dozens, maybe hundreds of these lone black holes.
Okay, so that could really change our senses of the galaxy's black hole population.
Dramatically.
All right, let's just recap the key points here for everyone. After only ever finding black holes with companion stars,
Scientists have now definitively identified the first lone black hole in the Milky Way.
and they did it using this really ingenious method, gravitational lensing, watching how the black hole's gravity bent the light from a distant background star.
Which allowed them to measure its mass at about 7 times that of our sun, confirming it couldn't be a neutron star.
And it's located relatively nearby, about 5,000 light years away.
And the big takeaway is that this opens a new window. It suggests there might be a vast hidden population of these solitary black holes roaming the galaxy.
We've basically confirmed a new way these things can exist and found a way to actually detect them.
It expands our picture of stellar death and galactic evolution. We're seeing more of the cosmic life cycle.
Definitely leaves you thinking. I mean, if this is the first one we've confirmed, how many more are out there?
Right. How many of these invisible giants are just silently drifting through space, warping space-time, completely undetected until now?
Makes you wonder what else is hiding in plain sight, just waiting for the right technique or the right telescope to reveal itself. A lot left to discover.
Always. The universe keeps surprising us.